All right. Well, good morning, everybody. Welcome back to Curiosity Corner Live. We're going to give everybody a few seconds to connect. But in the meantime, I can't tell if my computer's frozen or not. Are we good? I honestly can't tell from here. I'm going to keep talking as if we are. And if we're not, somebody just stop me at some point. But anyway, while we're waiting for people to connect, if you can hit button and make sure you subscribe to our channel so you don't miss out on anything. We have new videos every day at 3 o'clock. Now, still don't know if this is working. Come on, computer, you're embarrassing me. Work with me here. I don't know. Oh, there we go. Okay, my computer's caught up with me. Right then. Wonderful. So we'll move on. So like I was saying, we have new videos every day at 10:30 and 3 o'clock. Now, these can be demonstrations, they're design challenges, and some fun experiments that you can do at home. So now everyone's here. We'll get started. My name is Jared. I am your friendly science Viking, and I'm a guest engagement specialist at Great Lakes Science Center. Now, obviously, the center is still closed with everything that's going on, but we didn't want you to miss out on any of the fun, any chance to learn about science. So, with that in mind, today we're going to talk about density. Now, density is how heavy an object is compared to its size. What that means, let's say you have a 300-page book and you have a 30-page book. They're roughly the same size, but because our 300-page book has so many more pages, it's a lot heavier. That means it's a lot denser. To show you what I mean, we have two experiments. Our first is this little guy. This is our density bottle. Now, a density bottle has a lot of, let's call them interesting qualities about it. The first one is the fact that our beads here, I have some white beads, I have some blue beads, but they're hanging out in kind of the middle-ish area, which is odd. Normally, you have an odd, when you have something in water, it either sinks or it floats. It doesn't just hang out in the middle. What makes it even weirder is if I do this. Now, if we look closely, as soon as the water settles, as the impression goes, now our white beads have gone to the top, they floated up, and our blue beads have sunk to the bottom. Now, this is because of their density. Our white beads are actually less dense than water, I mean, they're lighter, so they float to the top. Our blue beads are more dense than water, they're denser, so they float to the bottom. But as we can see, hopefully we can see, our beads have once again congregated in the middle here, which is weird. It's like I put magnets in the beads. Obviously, I did not put magnets in the beads. So, to explain this, I got to tell you a little secret. My density bottle, this fluid here, this is not water. Don't get me wrong, there's water in it, but there's also a chemical called isopropyl alcohol, and there's salt. Now, isopropyl alcohol mixes with water really great. They like each other, they get along, they go to barbecues, it's fine. Salt and water get along really well. They go on buddy trips. I don't have another reference, I'm sorry. But the isopropyl and the salt do not like each other. They don't send each other funny memes. They cross the street to avoid each other. Not friends. So, when I mix my bottle up, I'm forcing the isopropyl and the salt to play nice. They don't like that, but for a moment they do, which lets my lighter than water beads rise to the top and my denser than water blue beads to sink to the bottom. But because the salt and the isopropyl don't get along, that's correct. Salt water does make salt water. Because they don't get along, they're going to separate again. Now, the isopropyl, funny enough, is also less dense than water. So it rises to the top. It's also less dense than our white beads. So as the isopropyl goes up, it pushes the white beads down. The salt is the exact opposite. It's denser than water, so it sinks to the bottom. It's also denser than our blue beads, so it sinks to the bottom, and it pushes our blue beads up. So in order of least dense to densest, oh, that's hard to say, we have the isopropyl, white bead, blue bead, salt water. And that is our density bottle. And honestly, that's just fun to do. All right. Our next experiment is a bit of a doozy, and it's also your challenge for today. So we are going to make us a homemade lava lamp. We're going to try. We'll see what happens. So what you need for this is you need an empty bottle, preferably after you've drank water out of it. Stay hydrated. It's important. We need water. Yes, we need water out of the bottle. Let's put it back in the water. Just roll with me here. We need food coloring. I've chosen red because red's my favorite color. Just look at my beard. We need a non-trademarked antacid. I've broken this tablet into fourths just so we can see. And we also need, pardon me, vegetable oil. Vegetable oil. I added like 3 syllables onto that. So, first things first. We're going to pour very carefully. I should probably be using a measuring cup. Too late for me to think about that now. We're going to pour our oil into our bottle. I'm going to fill it about halfway. Yeah, a little more. And then nobody tell my wife that I'm using her vegetable oil. Moving on. Stop it. All right. Next, we're going to add some water. And we're going to see what happens. So, can everybody see it? All right. Now, remember we talked about earlier about how the isopropyl and the salt don't get along? Well, funny enough, neither does oil and, well, anything else. But specifically, oil and water, they're not friends. So, look very closely. If I get there we go. We can see a layer of oil and a layer of water. Oil does not mix with anything. Water will mix with pretty much everything. But oil likes being left on its own. It is, in fact, the quarantine champion 2020. So I'm going to drop the food coloring on the floor. Try not to do that. Now, we're going to add food coloring. How much or how little is really dependent on you. I'm going to pour in a lot because, well, it's more fun that way. Now, we look very closely. If I don't block it, we can see that our food coloring drops have stayed in drop form. They have not dispersed through the oil. Oil doesn't want to play. But when it hit their water, I threw it on the floor again. Oh, well, it's gone now. Nothing to do about it. Now I'm going to stir this using a bamboo stick. 1, because this needs to be stirred. And 2, because I can wash the stick and then use it again later. So we're going to stir this up. There we go. Make it look real good. Now, I do not recommend shaking the bottle. If you shake it, we cause too many bubbles, and it's going to ruin our overall effect when we're done. There we go. There we go. Now we got a nice red flavoring there. So now, there we go. Now we're going to add in our non-trademarked antacid. Now it is denser than the oil and denser than the water, so it fell right to the bottom. But as it hits with water, it undergoes a chemical reaction and transforms into carbon dioxide gas. See how close I can get this? There we go. So now our bubbles are escaping, and it's taking our food coloring with it. There we go. No, you cannot drink this. I would not recommend it. There we go. And there we have it. There we have a homemade lava lamp. So that's our design challenge for everybody at home. And it's up to you. You can decide to use a different bottle. You can use more oil, less oil, more water, less water, a different color. For our younger viewers, maybe you get an adult to help you. And so for some of our older viewers, well, maybe you should have an adult help you too. But there we go. That's our talk on density today. Thank you so much for joining me. Now, before I let you go, Make sure you check back here at 3 o'clock. We'll be doing a follow-up, and I want to see what you've made. So if you're going to make a lava lamp, make sure you post it either on this video. Oh, Ben says tip it over. What happens when we tip it over? Okay, 5 points to Ben Smith. That's cool. Sorry, I got distracted. But if you make your own lava lamp, make sure you post it either on this video, on any of our social media sites, and make sure you tag us. Make sure you tag us with the hashtag StayCuriousCLE. We want to see all of your creations. We're very excited about it. Now, before I let you go, one last thing I want to say. I know things are scary right now, and I know that things are really uncertain, but we're going to get through this together. So, till the next, have fun, be safe, and as always, stay curious.